Good morning, everyone. And welcome to All Our Aggregates Are Wrong. So my name is Mauro Servienti, and the last name is pretty complex for Italian as well. So, and as you may guess by my accent, I'm Italian. So sorry about that. Up to you to decide if you want to be sorry because of my accent or because I'm Italian. So my goal for the next 45 minutes is to try to picture you a different way of defining context or boundaries, if you will. And so a different way to design your classes when we want to transition from the design and the high-level architecture to code. So I'm a remote worker. I work remotely 100% of my time. But the flat where we live is pretty small, so I cannot really work from home. So I rented a small office, and I used to bike ride to the office every single morning. And my favorite snack are bananas. So the problem with bike riding a backpack and bananas is that a banana is not really happy to be in a backpack while bike riding. So after failing a couple of times, you can foresee what failing means in this case, I decided to buy a banana protector. So I headed to Amazon.com, searched for the thing, and picked up the one with the best reviews. I haven't looked at the reviews at all. I don't want to know anything about what a review about a banana protector could be. So I added it to the shopping cart, and I immediately stopped here. And the architect in myself popped up saying, how such a thing could be designed? So I tried to understand what the backend, the Amazon backend in this case, could have been to satisfy such a UI, because that's the thing I was looking at. And the first thing I said to myself is, this one sounds like a nice-looking aggregate. So we could say that the shopping cart, is an aggregate. What about saying that it is a list of items, so items added to the cart, where every single item is identified by an item ID. There's a price, there's a quantity that we need to get the total amount for every single item, and then the total amount of the cart. We need to have the inventory because we want to display on the shopping cart how many items are left. And obviously, you need name, descriptions, and many other things to display things. And it's very easy to fall into the trap of saying we have data and we have behaviors as well. So what we can do when we have an item in the shopping cart, we can delete it from the shopping cart. We can save it for later. And we can change quantity. So it seems that it fits the aggregate definition. It has data and behavior. And is a sort of transactional boundary for things that you can do in a shopping cart. But if we look deeper and we put ourselves in the position of a business stakeholder and try to define business requirements for a shopping cart, things are not as simple as they seem. So let's start from the straightforward one. A businessman would say, we don't want the price to transparently change. Italians used to say, under the feet of the user. So without telling anything to the user. And this seems to be pretty straightforward. So what we can do is that the price is owned by something we can call sales. And as soon as an item is moved from the catalog to the shopping cart, we can copy the price over there. And now we're not relying anymore on some sort of relational integrity to get the price to the UI. Fine. We'll get back to this later. The second requirement could be, look, we want to be able to display, fake or not, doesn't really matter, we want to be able to display to users how many items are left in stock for a specific item in the shopping cart. It might be fake, because we want to try to push users to buy it. But anyway, it's an information we want to display on the shopping cart. And doesn't really seem to be a big deal. So that information is owned by warehouse, probably. So inventory is over there. And whenever we add an item to the cart, we copy the inventory value over there. However, availability changes over time. So time goes by, and other people buy banana protectors, or hopefully other things. And we end up in such a scenario. So we end up in the need of saying, whenever something changes in warehouse, we're forced to go to the shopping cart, ask the shopping cart, do you have any item in all your carts identified by ID XYZ? If yes, please update the inventory value to this new value. A third requirement could be, if the price of an item changes, we want to tell to the user, display a warning on the shopping cart page, telling the user, look, an item in your shopping cart changed price from whatever it was to something else. It could be higher, could be lower, doesn't really matter. We want to show the two different prices. It means that the information we stored in the cart so far is not good anymore. So we need something more in order to satisfy this new requirement. So pricing on its own is not enough. We need to introduce a new property, a new attribute in the shopping cart, and change the previous one. So let's say that we need something like that is current price and last price for every single item. And we are in a very similar situation like the warehouse inventory type of scenario. So every single time an item changes price in sales, we need to go to the shopping cart, ask, is there anything in your shopping cart that matches this item? And if yes, please swap prices and update the current one to the new one. And then the shopping cart UI, hopefully, will take care of showing the warning, because the two prices don't match anymore, hopefully. But there's a little bit of a complication here. That is, from the regulation perspective, we're not allowed to change the price and leave the item in the shopping cart, because the warning might not be enough, and we don't want users to buy stuff that now costs something different to what it was when they put it in the shopping cart. So sales, that is responsible for this behavior, needs to tell to the shopping cart, move this item into the save for later type of bucket. And I highlighted this in red, because this is pretty problematic. So we have two different contexts, and the red arrow identify a command that is basically crossing a boundary. And in the service-oriented architecture world, this is probably the biggest evil you can decide to implement in your scenario. Because this is basically telling to someone you have no control over to do something for you. And that should never happen. And obviously, as we said, this goes on for every single change that happens in sales. The big picture at this point is even messier. So if we take into account marketing, we need to copy information from marketing to the shopping cart. And let's say that we have shipping as well. So shipping want to display in the shopping cart estimated delivery times, but that information belongs to shipping. And now we have shipping that needs to query the shopping cart in order to say, is there something here? Yes, now please change the estimated delivery in the shopping cart. What's the problem with all these arrows? Is that autonomy is basically gone. So we have a huge, huge amount of coupling. And if this was a distributed system, we basically have a distributed monolith. It's very, you can picture in your mind that in a large system, having such a scenario basically means that you can change anything. There's no way to change anything without affecting something else. So it's very hard to respect one of the SOA tenets, that is, services or boundaries or contexts, depending on the lingo, should be autonomous. Where autonomous means that they should be free to evolve without affecting anyone else in the same system. The reality is that the shopping cart doesn't exist. It's very similar to the spoon of the famous movie. So why the shopping cart doesn't exist? Because every single context has its own view of the shopping cart concept. So we should be able to say that sales owns a subset of the shopping cart. So sales needs to say, the only thing I need to know is about prices and quantity, because I need to be able to tell someone, charge the credit card of the user by this amount. That's it. Shipping estimates are not really my business at all. So sales could say, well, my view of the shopping cart is just a list of items with a current price, last price, and quantity. That's it. And warehouse can do the same thing. There's a cart identifier, item identifier, quantity, and the current inventory for that item. Shipping can basically do the same thing, cart identifier, item identifier, quantity, and estimated delivery. Probably, we could say that quantity is redundant for shipping. Probably. We just don't know really what the business is about. So quantity might affect the delivery time, might not. I started from the assumption that it could. Marketing doesn't really care about the shopping cart. In a real scenario, marketing is super stable. So the only change that might happen to a name, a description, is for typos. We're not really going to reuse a product in a catalog. So if something changes that a product needs to be completely redesigned, we discontinue that product and we create a new one. We're not going to change the name from Banana Protector to Bike Wheel. That doesn't work that way. So do we need a shopping cart at this point? So all the contexts, or all the boundaries, or all the services, if you will, now they all have all the information they need to do their own little piece of work and satisfy all the requirements that we described so far. So we could say that if we move the cart identifier ID concept to sales, saying that conceptually, sales is the owner of the shopping cart concept in the system, not of all the data, but of the concept on its own, the shopping cart grain boxes in the middle are basically useless. What we did is that we just follow the coupling. So zero coupling in a system is utopic. There's no way to have zero coupling. So the only way to have zero coupling is to have no behavior in the system. This coupling, we need to accept that coupling, this coupling, and we need to follow the coupling, aggregating things in the same boundary based on coupling. So things that change together, or that needs to be changed together, or that a change of something affects something else, should be in the same context. And that's what we did so far. What's the problem now? Is that the information structure doesn't really fit users. So can we display a shopping cart now? Not really. So if we leave things as is, the only thing we can do is basically build 3 pages, well, 4, because we need name and description, and tell to the user, well, please try to remind the shopping cart identifier that probably is a GUID, and go from page to page and try to understand what's in your cart. That doesn't really work. At this point, it's very, very tempting to use a technical solution to solve a non-technical problem. So it's very easy to say, let's build a read model to satisfy the user requirement that is view the shopping cart page. So what we could do is that we can have multiple contexts, or boundaries, or services, or microservices, if you prefer, that push information into a central storage that can be some sort of Elasticsearch kind of thing, where we build this view model concept that is the shopping cart. We should be honest with ourselves. That's a cache. It's not really a view model. So we can give it a fancy name and decide that, well, yeah, we have view models now. We have projections. It's a cache. And it's a cache with a few issues. There's no ownership. So we have multiple things owned by different contexts that now flow into one single bucket where no one owns nothing. So if someone comes up and say, well, can we invalidate the price faster than the name and the description? Not really, sorry. So we end up adding technical solutions to solve what they are not technical problems. And with such a cache in an Amazon-like scenario, we have things that we cannot really cache. So on that page, there's a warning that says, this item cannot be shipped to Italy, because that item is from Amazon.com. So I intentionally went to Amazon.com, because I know that there are items that cannot be shipped. So I logged in with my Amazon.it account, and on most pages, so all the things that are not shipped by Amazon, basically, there's this warning, meaning that warning cannot really be cached. So it depends on the currently connected user. So we need to be able to evaluate that information on the fly based on the current user. What we might have noticed is that all these boxes, boundaries, they are basically sharing identifiers. So we have the item ID, that is a concept that everyone has. We have the cart ID, that is a concept that all the cart views in every single context have. So can we use those identifiers to compose a view model on the fly? We can use view model composition techniques to basically say, let's imagine that we have a browser that is trying to hit a URL, /products/1. If 1 is the primary key of a product, and probably is much more complex on Amazon.com, but for the sake of the sample, 1 is good enough, and that identifier is shared across multiple services, we could have some sort of infrastructure that intercepts the HTTP request and allows services to participate in the response, saying, let's build the view model on the fly and return that view model to the UI. So how can such a page be built? We have information coming from sales, the price. We have information coming from marketing, probably. We have information coming from shipping. We have information coming from warehouse, and so on. So all of the information on this page are owned by a service. Let's focus our attention on sales, for example. What if the infrastructure allows us to define a class such as this one, something called an handler, something that can handle an incoming HTTP request? If you're not familiar with .NET, don't focus on the code. I'm just using .NET as because it's the only thing I can write, basically. So the first thing such a class should be able to do is to say, I want to participate in a specific request handling that is based on the current URL. So the infrastructure scans all these classes and says, is there anyone that matches this URL? And this class says, well, if it is a GET request, and the controller is named products, and there's an identifier on the route, then yes, I'm interested. At this point, for all the instances that replied yes to the matching request, the infrastructure will call, please handle this request. And what's happening here is that we're basically extracting the identifier from the URL. We're setting up another HTTP request, but can be whatever we want. We can go on disk, we can go to a cache, we can go directly to a database. It doesn't really matter at this point. We're issuing this request to our own backend, the sales one, and then we're finally composing the response into that dynamic view model. A dynamic thing for non.NET people is basically a JSON object, a dictionary, an hash set, something that can be where we can inject things that are identified by a key. What else? So we're now able to say, if someone is asking for /product/1, all the services, sales, marketing, shipping, warehouse, whatever, can now participate in the response. But the problem is, what about rights? So what happens when we want to add an item to the cart? We're now able to display the banana protector page, but there's a button there, add to cart, with a quantity. We can apply the same technique in reverse. That's called view model decomposition at this point. The important thing is that all the three services, they all need the quantity for different purposes. So it happens to be the same value, but from their own perspective, is something they treat completely differently. Can we apply the same technique, saying, let's say that there's a browser, or whatever. At post time, to post /shopping cart /, we're posting that little JSON object that is basically an ID and a quantity. The infrastructure intercepts the post request and allows all the interested parties to inspect the post request, extract the values they are interested in, and post those values to their own backend. Since they share identifiers, now basically the incoming item ID is enough for all of them to understand what we're talking about. And from the code perspective, you can basically do exactly the same thing. So we now have a shopping cart add post handler that is still an iHandle request type of thing that has another interface. Keep in mind that this thing can handle errors, and we'll try to understand later what does it mean. We have the same matching logic. This time, we're matching just post requests. So there will be multiple instances of this thing coming from different services. They will say, is the shopping cart request? Yes. There's a shopping cart in the URL. Is the post? Yes. So I want to handle it. And at handle time, we are doing something slightly differently. So we're extracting things from the incoming post request. We're grabbing the item identifier from the URL. We're grabbing the quantity from the HTTP post form. And we're grabbing the cart identifier from cookies. That can be whatever you want, obviously, depending on your context. And instead of talking to our backends through another HTTP request, we're sending a message through a queuing system. We want to be as safe as we can. So obviously, imagine that you have an incoming HTTP request, and you have 3 actors trying to handle that request in some way simultaneously. If they all issue another HTTP request, what could possibly go wrong? So it's the risk that something goes badly is very, very high. We want to be able to reduce this risk at the minimum, since we cannot really have transactions bound to an HTTP request. What we're doing is basically saying, let's say that there's an incoming HTTP request, all the actors, well, they could do whatever they want. But in this case, the suggested action is send a message on a queue. So we still have a problem. We have 3 actors or 3 components trying to talk to the queuing system. There's no transaction keeping them together. So if the second one fails because the RabbitMQ broker is not available anymore, so there's a network outage, we have a message that is gone from the first one, the second one fails, and oops, now we have basically data corruption on the back end. Because one of the services will have this concept of, I have something in the cart, and all the others knows nothing about that. In the best case, one of these services is one of the children's service. So if it were in our scenario, it could be warehouse or shipping, where it's conceptually a child item. So that item is basically an orphan item. It will just waste space on a database, and who cares, we could say. But if that's sales, now sales has a master and a detail, a piece of a detail, and there's no other children in all the other services. So we have a problem now. However, one thing you might not have noticed is that at the handle time, we're passing in a request identifier. And we're passing that request identifier along to backends. So now backends have the concept of correlation ID. So they can correlate some data at the backend level with a specific incoming request. If something goes badly, the infrastructure will call on request error, passing in the same request identifier. And all the actors, all the components that participated in that incoming web request will send a message to their own backend saying, please compensate the previous request. Do whatever you want, I just don't care. That can be delete data. Try to go to the credit card system and say, please, don't charge Mauro's credit card, whatever. It's not really the problem of the infrastructure, what to do. What's the easiest way to handle such a thing at the back end? Is a sort of event-sourced type of infrastructure. In reality, it's much simpler. So we're just appending actions in our storage. So the cart at the back end won't be just a single item with a quantity. Whenever we add an item to the cart, even if it is the same product ID, we're adding a new row, and a new row, and a new row. And each row is basically, they are all sharing the cart identifier and the product identifier, but they are identified by request IDs. So basically, whenever something fails, we can send a message to the backend saying, please undo, or again, compensate that request ID. And what a backend could do is simply delete that row. And now we're back in a scenario where everything is behaving as expected. The important thing at this point is that there's no orchestration at all. So there's no one that knows what's going on into that type of infrastructure. You can imagine that the simplest solution to build such a composition-decomposition type of thing is to code that in order to build that page, I need to talk to warehouse, shipping, sales, marketing, whatever. And your code will instruct in an orchestration type of approach, services to do something. That's coupling, once again. Whenever we need to add something new to the UI or remove something from that UI, we need to go to that central place where everything is coupled and change the code there. What we want to be able to do is simply drop a DLL in a bin directory, restart the service just because .NET requires us to restart thing in order to pick up something new, and go on. So handlers, or request handlers, should be able to be transparently added to the system without telling to the infrastructure nothing. That's the very important bit. What we were able to build so far is basically that we have full vertical slices, each one handling a specific business capability or a specific business requirement. And now they're able also to participate in the UI. So they own their own view model composition, decomposition piece that is capable of participating in an HTTP request or response, or both. But we're not done yet. So these services, in some way, needs to communicate with each other. So There's a couple more requirements in the Amazon shopping cart I want to have a look at. We want to be able to notify users if the shopping cart hasn't been touched for a week. So we put stuff. My wife is very good at that. So from her perspective, and it's interesting because most people I know do that, there's the wish lists on Amazon. My wife doesn't use wish list. She puts stuff in the shopping cart and move things from save for later to the shopping cart. That's her type of usage of the shopping cart. So she receives a ton of notifications from Amazon saying, you have stuff in the shopping cart you haven't bought yet. And that's works very well. She buys a lot of stuff. Anyway, we want to be able to notify users if they haven't touched their cart and there's something in for a week. And if they do nothing, we want to wipe carts after a month. So we want to just to save space on servers probably, but that's a requirement. Now we have an interesting problem that if information are scattered around multiple systems or services or boundaries, if you will, now we want to be sure that they communicate with each other in some way. So let's say that the one owning these two requirements is again sales. Sales is the one that owns the concept of the cart. So sales is the one that can say, I want to notify, I want to annoy, I want to wipe. Sales is not the one responsible to send the email, though, because sales knows nothing about email templates, what we want to tell to the user, and stuff like that. So whenever we add an item to the cart, that is the action that the user is doing, what basically sales does is that it sets a timeout for itself, saying, well, send me back or call me back within a week, because I need to check if something in this specific cart has changed or no one touched this cart during the last week. And sets a timeout for itself, saying, well, do the same thing in 1 month, because I want to be able to wipe that cart within a month. After a week, what happens is that an event is triggered. That event goes to the boss and is received by marketing in this case. That is the one interested in knowing we have 1 week stale cards. And what marketing does is create the email, talk to the notification system, sends the email to the user. A month later, if nothing changed, sales raises an event again. In this case, we have 2 subscribers. So both shipping and warehouse are interested in this because they have a view of the shopping cart. So they are owning a piece of the shopping cart. So if something needs to be wiped, they need to do the same thing. So they will receive the event, and they will wipe their own view of the cart. At this point, given that sales already wiped its view of the cart, this eventual consistency is not a problem at all. So in the worst scenario, warehouse can receive the message a week later. It's just a waste of space on disk. No one will see those items as orphan items. So they're just orphan items, since sales already deleted the master of the shopping cart. Given that we have vertical slices, what's the important side effect, in quotes, of this? That events can be as thin as name and identifiers. We do not need to share anything across services other than super stable things. If an identifier changes, we have a much larger problem. So coupling is not the problem. At this point, it means that there's basically 0 coupling across services, because the only information that events carrying along is just the type of the event that identifies something that happened in the past, and a bunch of IDs that are stable. In this case, we have full vertical slices, super autonomous, that are free to evolve without affecting each other. And the final big picture is that we have behavior and data And from my perspective, behavior is much more important than data. Data and behavior sounds better, but behavior is the important part of things, not data. Data is a side effect. Since we have behavior, we have data that needs to be there. But behavior is the thing that we should look at. The bus is the thing that is gluing all these actors at the back end. And all these actors or components or services or aggregates, if you will, have this view model composition components that allows them to participate in the UI composition and decomposition actions. I have a huge demo to demo this, but obviously in 45 minutes is impossible. So the demo is available here. It's a .NET demo to represent what we just described. There's 38 projects, so it's a bit complex. That's why 45 minutes are not enough at all. If you have any problem running the demo, just drop me a message on Twitter, email, whatever. Raise an issue in the GitHub repo, and we'll fix that. We have Udi Dahan talking about service boundaries a little bit. So a few notes from Udi about service boundaries. That is the main topic of today, basically. And before letting you go, a couple of takeaways. So boundaries are the key to success. If you fail finding your boundaries, coupling will basically kill you in the long term, because we'll drive you into the distributed monolith type of system. That is basically the worst of both worlds. So we said that the monolith is super bad. Distributing a monolith can only be worse. So the other thing is that every single time you're faced with, we need more technology to solve this problem, go back to the whiteboard. You might find that you defined your service boundaries in the wrong way. So another thing that I realized during these last 15 years is that we used to say, try to model the user mental model. That's probably the worst thing we can do. Or it's probably the worst thing we can do when we transition from the result of the chat and discussion with domain experts to code. Because at that point, it's very easy to, so users, business analysts, and domain experts tend to think and present data in terms of data presentation, what they expect to see on a screen. And they describe things based on data and interaction based on those views. So it's very easy for them to say, we have a shopping cart, and you can change the quantity of the item in the shopping cart. But that things happens in warehouse, shipping, and sales. They're not telling this thing to us. So it's very easy to end up designing a shopping cart that we don't really need. The other thing is, do not name things prematurely. So the typical sample is, you're talking to a domain expert, and they tell you, we have the concept of a customer, and customers can be premium, gold, Indu yesterday was saying, silver, platinum, executive platinum. That immediately transitions in our mind in public class customer, public property, first name, last name, status. And then we have already defined the boundary. Unfortunately, the next requirement will be, if the customer is premium, then the price should be this. So we now have the customer-bounded context that needs to be able to participate in the price definition. And then this is one of those arrows that cross a boundary. Okay, so we just defined coupling. So naming things prematurely is basically evil. It drives you, and it might drive you in the wrong direction. What we need to follow is basically the coupling, so following the behavior of the system. We should group data that change together. So the customer status and the price should be in the same place. Does it have a name? Not really. We cannot really define the customer end price class. It doesn't make sense at all. It's in the sales context, probably, that owns the price thing. One of the interesting ways to achieve this is to use anti-requirements technique. So it's basically to ask stupid questions. There will ever be a scenario in which, based on the customer's last name, we're going to apply a discount. Probably no. In which case, it's very easy to say the last name should not be in the same place as the price. And obviously, follow the coupling. Once we have defined the boundaries, we can then apply view model composition and decomposition techniques in order to avoid more technology and more problems and present data to the user. Once we have done all of this, we probably escaped the monolith and the distributed monolith. One of the sad things of this is that it's very easy, and you should expect to fail at least the first time. So it's very hard to get this right at the very first attempt. And it takes a long time to understand boundaries and to get them right. So failure has to be expected, and we should learn from failures. That said, thank you very much. If you have any questions, just raise your hand. Otherwise, enjoy the rest of the day.
In that example, you had the sales boundary, firing an event for an expired cart, and then the marketing service needs to then compose an email that gets sent out. So that seems like there's another view model composition in there somewhere that's not in a browser, that's going to be back-end server side.
Yep.
So who owns that part? Who composes the data from all those to generate the email?
Yeah, so to expand a little bit on the question, the scenario is marketing needs to send an email. Probably the email needs to tell something about the cart. So marketing cannot simply say, well, you have an expired cart somewhere. We need to show something about the cart, probably cart items, give a link to the cart, and stuff like that. So we again have information coming from different services. An interesting approach to that is, again, view model composition type of thing. So an email is pretty easy to achieve. So in a real-world scenario, what could happen is that marketing talks to a notification service that is an infrastructure type of facility in the system and says, please send this email using this template to this address. The only thing that marketing owns is the destination address, because marketing is the one interested in talking to the users. So they own the email address of the recipient. What the template does is basically that the template is very similar to an HTML page. So the template rendering engine will load the template, start the filling process of the template. There will be appenders or request handlers, very similar to what we saw in the code, that can participate in the template rendering process. When the template is rendered, that HTML is shipped through an email. And that the very same thing can be done with a PDF. So we could say that we need to generate an invoice, and that invoice must be a PDF. We can do exactly the same thing. Probably the only difference is that with an email, we will redo the same process every single time we need to send the same email, even if it's exactly the same. With an invoice, we render that once, and then we store it. It's much simpler, probably. And then we also satisfy legal requirements that we need to be sure that the invoice doesn't change over time. Does that answer the question? Good. Going once, twice, hop.
So how does this, so this focused on the view model, and I am in my head, I imagined different teams, a team working in sales, a team working in the warehouse. So there are other things that the warehouse team might care about. So they might want to know, oh, there's not enough banana holders in stock to ship this. That has nothing to do with the view model from sales' perspective.
Yep.
So how does this situation change at all to handle that?
It probably doesn't. So the fact that warehouse has the information about the quantity in shopping carts allows warehouse to apply some sort of machine learning type of approach, saying, well, I can predict that 50% of the shopping cart will be checked out within the next week. So it means that I will go, I do not know how to say it in English, so the negative stocks, negative inventory very quickly, so let me refulfill my warehouse. And that type of behavior is completely independent from other services. So the interesting thing of vertical slices is that now we can change requirements in a single place without affecting anyone else. So another interesting requirements in this scenario could be sales might say, if it is a platinum customer and the difference in price change is less than 1%, don't tell anything to the customer. Sell at the old price. So we're going to lose money, but we just don't care because they are platinum customers. So shipping doesn't really care about this. Warehouse doesn't really care about this. It's just it's something that can change and should change only in the sales context. So now we are free to evolve different boundaries without telling anything to anyone. And if something needs to be told, we have events, thin events. We can start publishing a new event, and someone else can start subscribing to this new event and do something else.
So it sounds like the view model, in the example you gave, the view model, is that owned by sales?
That's a very good question. No. In large complex systems, the view model, or to be precise, the template, so the HTML, CSS, JavaScript as well, so common JavaScripts as well, are owned by a service called branding. So there will be a third-party service, so someone else that owns that monolith, because that's a monolith in that case. In which case, that's needed. In scenarios like the Amazon one, the Booking.com one, so user-facing type of things where we want to have full control over the user experience that the users have. It means that we do not really want to allow a single vertical slice that probably knows nothing about all the others to affect how something is rendered on the UI. In which case, we want to have, in order to have coherent display of things, there's a fourth, fifth, whatever, sixth service, branding, that owns the thing. On the complete other side of the spectrum, there's systems like Salesforce, SharePoint type of things. So things that by design, they do nothing from the business requirement perspective of the customer, and the business requirement is built by the customer into the system that is there for power users to build up things. In such a scenario, services, they probably own also the HTML fragment. So we can, instead of having in the vertical slice, instead of having in this vertical slice only the view model composition part, we'll also have in the slice the HTML, the CSS, and the JavaScript. The side effect is there's magic happening in the UI in order to glue things together, and there's the risk that sales does something that breaks someone else. So guaranteeing consistency is much more complex. And then there's the problem that you cannot really apply this thing transparently to the technology stack of choice at the UI level. So if you're choosing React, you have to do things in a certain way. If you picked up AngularJS, you have to do things in a certain way. If it's WPF, you have to do things in another way. So the UI technology of choice affects the way you're going to change that last brick in the vertical slice. Oh, we're over time. Thank you very much. Have a great day. I'll be around the entire day. Just